Welcome students in the lecture series of machine learning. So we will talk about reinforcement learning. If you remember that in machine learning there are three kinds of learning. One is supervised, unsupervised and reinforcement learning. So we are talking about, we will be not going into the depth of reinforcement learning, but this gives you the brief idea what reinforcement learning is. So reinforcement learning is a type of machine learning where an agent learns to make decision by interacting with an environment. So what is an agent? Agent is something which can perceive the environment through sensors and do some changes in the environment also through actuators. So that becomes an agent. Okay, so your vacuum cleaner, if it is automatic vacuum cleaner that has some intelligence, is an agent. It can sense the dirt, clean, wipe out that area and then stop. Okay, and it does the exploration inside the room. Wherever it finds some dirt, it will automatically clean up. So this is a perfect example of an agent. Your rovers can be also classified as agents, because they are sent to different planets and celestial bodies to explore the area. So the agent receives the feedback in the form of rewards and penalty. If you are doing good, you will receive a reward. If your decision is wrong, you receive a penalty. That is some detection of some points. And its goal is to maximize the total reward over the period of time. So what do we have in this situation? The terminologies or the keys words. The first one is the agent, the learner or decision maker, the environment in which the agent is operating, the states. We have certain states of the agents, okay, that represents the current situation. Okay, so if you make a set of states, so in that set of state you should consider every possible situation in which the agent can go or, okay. So we can have action because you are in certain state, so you have to choose the actions according to the state. Then we have a reward. Okay, feedback from the environment is sent to the agent, so the agent gets reward or penalty. And the policy, so the strategy that maps the states to action. So that means it's a strategy that maps the states to action. So you have taken this action, you go into this state and you can achieve a final goal through the policy. The value function, expected return or total reward from a state. Then Q value function, expected return for taking an action in a state. So what happens? The agent is actually continuously working in reinforcement loop, that is known as RL loop. The agent observes the current state, what is the state it is in. It selects the action based on its policy. The environment returns the new state and a reward. Okay, and the agent updates his policy to improve the future decision, and this step is actually repeated. So it is working in a continuous reinforcement loop. So types of reinforcement learning, we can have model free versus model based, value based versus policy based or versus actor critic. So model free means the learns by trial and error. Example Q learning and SARS A. Model based learning, we can have tries to model the environment, that what kind of a environment I am actually encountering. Value based learns functions values, example is Q learning. Policy based, okay, directly learns the policy, example reinforce. Actor critic combines both the approach, that is the value based and policy based. So these are the types, variants. So some of the RL learning algorithms are Q learning, deep Q networks, SARSA, policy gradient methods, proximal policy optimization, PPO, and A3C, asynchronous advantage, actor, critic. So these are the some learning algos. So applications of reinforcement learning, one of the most easy to remember is robotics, game playing, that walking manipulation in the robotics, game playing, AlphaGo, OpenAI. Okay. Recommendation systems, autonomous vehicle, and finance for stock market trading. Challenges in ML is exploration versus exploitation. Exploration means that suppose you are on a state X and you have to go perform some action. So you calculate, if I go to various places, what I can encounter, whether I'll get the reward or I'll get the punishment. So that is known as exploration. So if you are exploring, keep on exploring, keep on exploring. So you may take a lot of time, you waste a lot of resources. Exploitation is that whatever you have learned, on that basis you make a decision. So which one to choose in a situation is very challenging. Sparse or delayed reward. So you are in such a state, okay, so system operates in such a combination of states, and you are in such a state that whatever you actually observe, and if you are taking an action, so the reward may seem to be very low, okay, and that could be a temporary situation or it could be the overall situation. So high dimensional state spaces, yeah, if the agent have more functions, the environment has more kind of input, and you have more kinds of actions that you can take on those inputs, so state space grows and becomes humongous. To search the entire state space is not possible. Now we can have sample inefficiency. So whatever the samples you are giving to an agent may be not sufficient enough, okay, to represent that complex environment in which the agent will work. So what we can have? We can have some learning task also. So learning task defines what agent is supposed to learn, how success is measured. In reinforcement learning, learning task involves the agent learning how to act to maximize reward through interactions with environment. So a component of learning task: objective, environment, agent, performance metric, and feedback. So this is a task that is being defined in reinforcement learning. So objective means maximize long-term rewards. Environment, the world of the simulator in which the agent interacts with. An agent, a learner that improves the over time. Performance metric, usually cumulative reward. Feedback type, reward signals. So by this we have just introduced that what a learning task is. That it's been considered as I've considered it in a separate slide. So you have some idea of the key terminologies and the terms associated with reinforcement learning. Thank you, students. That's all in this slide.